All right, inequalities. It's essentially the same thing we've been doing all week. We're trying to find what is x, what is the mystery number. But in this case, there's going to be an infinite amount of answers. And that may seem intimidating, but it just means that you could put in more than one number for x. So let me start off simple for you here. I think I showed you this example earlier in the week when I was first trying to explain to you why we do inverse operations, why we subtract 3 to the other side, and in this case x equals 4. Well, if we get rid of the equal sign and we make it an inequality sign, like say less than, you would still solve this the exact same way. All right, you would still get x by itself by subtracting 3 to the other side, and you would get 4, but now in this case, x is less than 4 instead of x is equal to 4. So what does that mean? That means we can't use 4 in this equation. We can't use 4 as x. If we substitute in a 4 for x, we get 4 plus 3 is less than 7, and we get 7 is less than 7, and that's not true. 7 is not less than 7. 7 is equal to 7. So it doesn't work. So what does this answer actually mean? X is less than 4. It means we can use any number we want to for x that is smaller than 4. So we could use 3, we could use 2, we could use 1, we could use negative 5,026,000,026. All right, that's why there's an infinite amount of answers. The negative numbers go on forever. So let's just say we use 3. Let's substitute in 3 in for x. And we get 3 plus 3 is less than 7. 6 is less than 7. Yes, that's true. So we can use 3. All right. If this symbol was less than or equal to 7, we would solve it the same way we solve it if it was an equal sign. And we would get x is less than or equal to 4 because we subtracted 3 to the other side. Now we can use 4 because it's less than or equal to. So if we substitute in a 4 for x, we get 4 plus 3 is less than or equal to 7, and we get 7 is less than or equal to 7. Now that works because it's less than or equal to. Because of that line right there, it works. So you got to pay attention to your symbol. If the symbol is just less than, you got to use a number smaller. If it's less than or equal to, then you can use 4. All right, on the do problems today, the math is pretty simple. They're all just easy two-step equations. You don't have fractions for your coefficients. You don't have quantities in parentheses. You don't have x on both sides of the inequality sign. You just have simple two-step equations like 3x plus 5 is equal to, or I'm sorry, we'll say is less than 17, something like that. So it's pretty basic on how to solve these. You should just subtract 5 to the other side, and you divide by 3. So it would look like this. 3x is less than 17 minus 5, which is 12. So we know that 3x has got to be 12, because 12 plus 5 is 17. All right, so then we divide by 3, because we're multiplying by 3 over here. We're moving it to the other side of the equation. We divide by 3 and get 4. So 3 times 4 is 12. 12 plus 5 is 17. And we would end up with 17 is less than 17. And that doesn't work. So even though 4 is what we get for our answer, it's not an answer that we could use. So that's what makes inequalities a little bit tricky, is that you solve them the same way, but you have to read that sign. This doesn't say x is equal to 4. It says it's less than 4. So just like that first example, you could use 3 or 2 or 1 or whatever number that's negative. You could also, if we're not using whole numbers, you could use 3.9. 3.9 is a teeny tiny bit less than 4, and if you substitute in 3.9 for here, you're going to get a number that's 16.9 or something that's teeny, just a little tiny bit smaller than 17. All right, the reason I'm telling you this is because on your do problems, you might have a problem that looks just like this, but it'll have like a semicolon or some kind of symbol and then a number here, like say 4. And what they want to know is, does that number work in this inequality? Can you substitute that number in for x and make this statement true? And in this case, no, you cannot, because it's not less than or equal to. If you substitute in a 4 for here, you get 3 times 4 is 12. 12 plus 5 is 17, and you end up with 17 is less than 17, which is not true. 17 is not less than 17. It's equal to 17. So you got to solve these problems just like we've been doing all week, and then ask yourself yes or no. Does this given number work in this problem? Now, these can get a little bit trickier when your coefficient in front of the variable is a negative number. So let's just do that. We'll do the same problem, but I'll make 3 negatives. So 3x plus 5 is greater than or equal to 12. I think I had 17 down there before, didn't I? Yeah, 17. And we want to know, is 4 going to work for this problem? So you solve this, just like we've been doing. You subtract 5 to the other side, and that gives you 12. So we have negative 3x is greater than or equal to 12. And then you divide by the coefficient, and the coefficient is negative 3. So I didn't really stress this in the first 3 days, but this is a common mistake I see here, where people just write positive 3 over here. They get the dividing right. They know that this is being multiplied, so they divide over here, but they change the negative to a positive because you're so used to, when you move it across to the other side, you change it, you do the opposite, you do the inverse. Well, you're doing the opposite of the multiply, divide, add, or subtract. You're not necessarily doing the opposite of what the sign is. So this isn't 3 minus x, so you don't do plus. This is negative 3 times x. This is multiply. So the opposite of multiply is dividing. So you are doing the opposite when it comes to multiplying and dividing. You don't have to change the sign. In fact, you cannot change the sign. If you do, you're going to get it wrong. Whenever you divide a coefficient, you got to keep its sign. So it's negative 3 times x. Over here, it's divided by negative 3. All right, so you end up with negative 4. Now, this is where inequalities get tricky, is when you divide or multiply by a negative coefficient. If you start off with a negative coefficient, as soon as you see this in the problem, if you have a coefficient in front of your variable that's negative, you're going to end up having to flip this inequality, because you're going to have to divide that negative 3 to the other side eventually, and that's going to flip your inequality. So this is going to become less than or equal to negative 4. All right, we can check this. Let's say you forget to flip it, and you say x could be anything greater than or equal to negative 4. Well, greater than a negative number means closer to 0. If you're $4 in debt, $3 in debt is better. It's closer to 0. Maybe debt is a wrong way to look at this, or a more difficult way. Think of temperature. If it's negative 4 degrees, what's a warmer temperature? What's a bigger number? Negative 3, negative 2, 0. You know, anything closer to 0 or above 0. So a number that's greater than negative 4 is negative 3, for example. So if this statement is true, if we did our math right, we should be able to substitute in a negative 3 for x, because negative 3 is greater than negative 4. Now you substitute in a negative 3 for x, and we're saying negative 3 is greater than negative 4. That's true, so let's put a negative 3 in for x here. And see what we get. If we put a negative 3 in for x, we get negative 3 times negative 3 plus 5. Negative times a negative is a positive. So we get 9 plus 5 is 14. And we're saying that 14 is greater than or equal to 17, and that is not true. 14 is smaller than 17. It's not greater than 17. So it doesn't work. All right? It's not that we made a mistake on our math. Negative 3 is going to work. It's that we didn't flip our sign. So let me redo this problem. Minus 5, you get 12, divide by negative 3, and you get negative 4. But when you divide it by that -3, you have to flip this sign. So it's got to be less than or equal to -4. So what's a number that's less than -4? What's a temperature that's colder than -4? -5, for example. So let's substitute a -5 in for x. -3 times -5 is positive 15. 15 plus 5 is 20, and 20 is, in fact, greater than 17. So that works. So if you forget the rule for flipping the inequality when you divide by a negative, check the answer that you get. You can always check it by substituting back in at the top and see if it works. And that's kind of what you're going to have to do on the assignment today. You're going to have to solve the problem and then substitute in the number that they give you and see if it works. If it doesn't work, you say no. If it does work, you say yes. That's how you solve these problems.